back to the example that we discussed earlier, we were interested to look at smoking among university students. We select a sample of university students, collected data for a number of variables from them, and we intend to use the information that we collected to say something conclusive about the population. In other words, we are trying to infer or generalize the result from the sample to the population at large. The data that we derive from our sample can be examined in two ways. We often divided them into what we call as descriptive statistics or inferential statistics. Descriptive statistics are used to describe the characteristic of the sample in the study. In other words, we are simply describing what is and what the data shows. In a research study, we may have lots of measures, or we may measure a large number of people on any variable. Each descriptive statistic reduces lots of data into a simpler summary about the sample and the measures. In our case, we could summarize the average BMI from the sample of our university student using the mean. We can also run a frequency distribution to find out the proportion of students who smoke or don't smoke. Remember that the ultimate aim in any statistical analysis is to make conclusions about the population of interest based on the data collected from the sample. This means that what can be said about the population at large based on the sample values. Statistical inference is used to connect the sample statistics to the population parameters. Inferential statistics are used to investigate questions, models, and hypotheses. In many cases, the conclusion from inferential statistics extend beyond the immediate data alone. For instance, we use inferential statistics to try to infer from the sample data what the population thinks. Or we use inferential statistics to make judgment of the probability that whether an observed difference between two groups is a dependable one or one that might have happened by chance in this study. There are more than 100 over statistical tests in making inference. All these techniques are rooted in statistical theory and probability distributions. The most common used technique is the standard normal distribution. Other distributions include student t, chi-square, f-test, and etc. Therefore, which statistical test to use on your data depends on population, how samples were taken, how variables are measured, and your aim for conducting the analysis. In other words, whether you want to test the hypothesis value in the population or to estimate the parameters in the population. For example, you might want to know whether males and females in this sample differs in their BMI. Note that earlier, BMI is measured as a quantitative variable. A test of significance such as the independent t-test can be used to analyze whether there is a difference in BMI between the two groups. And if you would like to compare if smoking status, which is measured as a categorical variable, differs between male and female, you will need to perform a chi-square analysis. T-test, chi-square, ANOVA regression analysis such as logistic regression are commonly used in public health. There are other multivariate methods like factor analysis, multidimensional scaling, cluster analysis, discriminant function analysis, and so on. The details of the theory and the application of these statistical tests will not be covered in these introductory sessions, but will further discussed in your advanced statistics module in future. This concludes the third and the last part of this lecture. In summary, we use inferential statistics to make inferences from our data to more general conditions, while we use descriptive statistics simply to describe what's going on in our data. Large quantities of data collection can make sorting of data difficult. Therefore, it is important to apply appropriate statistical procedures to enable useful and meaningful interpretation of our data. Before I end, I would like to summarize the main points in this lecture. We now know that statistics has contributed significantly in the efforts to improve public health, such as increase life expectancy, prevent disease and disability, increase access to health, and so on. When we want to collect data, we select a sample of individuals, rather than the entire population of interest because it is too expensive or simply not possible to include the whole population in our study. We collect the data from sample. We usually collect information about our sample because we are interested with the characteristic or known as variables of the population from which the sample was drawn. The characteristic of interest can vary between subject or objects. Using descriptive and inferential statistics, we use the result from the sample to describe the population and draw conclusions about the whole population. The type of statistical test to be performed while making an inference depends on the population, samples, how data were measured, and the aim of your analysis, either testing a hypothesis or making a prediction. These are some of the recommended texts for this lecture. You can also refer to any statistical books that are available in the library or bookstore. Thank you.